All right, this is Math 208, Week 3, Section 3.3, Finding Intercepts from an Equation. So in this slide, this problem, what we're being asked to do is we're being asked to essentially draw a graph using a particular technique where we find the intercepts for a graph. And now what that means is I am going to take the equation, and I'm going to write it over here. Negative 3x plus 5y equals negative 15. All right. Now, what the technique is, it's finding the intercepts. And what that means is you've got your XY table. All right. And in that XY table, we are going to let x be 0, and then we're going to figure out what y is equal. And then we're going to let y be 0 and figure out what x is equal. All right. And that's a very specific technique because when you let x equal 0, you're finding the y-intercept. And when you let y be 0, you're finding the x-intercept. And so that's what they mean by finding the intercepts. All right, so I'm going to move this down here. Well, yeah, get it out of the way. And so let's do this first one. So we're going to find y when x is equal to 0. So it's going to be negative 3 times 0 plus 5y equals negative 15. So this becomes 0 plus 5y equals negative 15. And so we can kind of ignore that 0 because that's meaningless. And now we're going to divide by 5 both sides to get the y all by itself. And we end up with just plain old y is equal to negative 3. So that tells us, and I'm going to get that and put it kind of out of the way here, that tells us that y is equal to negative 3. All right, and so now we're going to do the same thing, only this time it's y that's going to be the 0, and we're going to figure out what x is. And so we're going to get our pen, and we've got negative 3x plus, and then this becomes 5 times 0 equals negative 15. And since 5 times 0 is 0, I'm just going to kind of save us a little bit of a step, and that becomes negative 3x equals negative 15. So now I'm going to divide both sides by negative 3, and that ends up giving us x is equal to positive 5. So now we know that x is equal to positive 5 when y is equal to 0. So there is our table, our resulting table. And so I can move that up here. I'm going to shrink it down a little bit. And so with that, we now know our ordered pairs, 0, negative 3. And the other ordered pair is 5, 0. So those are our two, and I'm going to get these guys out of the way because we don't need them anymore. And these are the two ordered pairs that we're going to graph for this equation. All right, so this equation is the goal, right? And so let's plot these. Now, where is 5, 0 going to be? Well, it means 5 on the x-axis, 0 on the y-axis. So that means our dot is going to go right there. And then how about 0, negative 3? Well, that's going to be 0 left or right on the x-axis, but we're going to go down 3. And so I'm going to put it right here. And so our dot ends up going right here. And I need to move him out of the way. And our line becomes this. Now, could we find a third point to verify that we've done everything correctly? Yeah, and that's probably a good idea. But in this lesson, we're specifically being told to commit to your two intercepts, and once you have two dots, you have enough information to draw that line. So here we're being asked to again find the intercepts for this particular graph. And so the idea is, first thing we're going to do is we're going to write that equation over here, x minus 2y is equal to 8. And then we know that we need to create that table, and we're only going to have two values, two ordered pairs. One where we have the x is 0, and then one where we have the y is 0, and then of course we're being expected to find the other one. So here's the table. I'm going to kind of put it out of the way for a second. And so let's do it. So x is 0 minus 2y is equal to 8, because that's what I'm doing. I'm letting the x be 0 and then calculating y. So of course that gives us negative 2y is equal to 8. And then I'm going to divide both sides by negative 2. So we end up with y is equal to negative 4. All right, so there's our calculation, so that when x is 0, y is negative 4. All right, and so I'm going to put that in there. So right there. So when x is 0, y is negative 4. And now we need to figure out, well, what is x going to be if y is 0? And so what is x going to be if y is 0? All right, and that's supposed to be an 8. All right, and so this part is 0, so we end up with something really easy. X is equal to 8. Boy, that doesn't get much easier than that. So when y is 0, x becomes 8. X is 8. And so there is our table. And now I'm going to move that guy out of the way a little bit. And I'm going to move our little calculations aside because we don't need them anymore. And the idea is, now that we have our table filled, we can identify the ordered pairs. So the ordered pairs is 0, negative 4. And then the other ordered pair is 8, 0. And now we're going to graph these ordered pairs for this equation. All right, so there's the equation. And I'm going to move over here and let's make it a little bit larger. Okay, so where is 0, negative 4? Well, 0, negative 4 is going to go down here. And then where is 8, 0 going to go? Well, that's going to go way over here. And I'll put the dot right there. And now we have our 2 points, our 2 intercepts. We have the x-intercept because it's crossing the x-axis. We have the y-intercept because it's crossing the y-intercept, and the y-axis, and there is our resulting line. So here, more of the same. We're going to find the intercepts and then graph the equation. And so I'm going to make our information smaller because we don't need it so big. And so I'm going to write 7x plus 4y is equal to 28. So there's our equation. And now, of course, we're going to make that xy table. And we know that x is going to be 0, we're going to calculate y. And then y is going to be 0, and we're going to calculate x. So I'm going to get that out of the way. So let's start doing the work. So I'm going to first put x as 0. So we have 7 times 0 plus 4y equals 28. So that becomes 0. So that goes away. And then I'm going to divide both sides by 4. And we end up with y is equal to 7. So when x is 0, y is equal to 7. And so let's put that in right here. And then now we have to figure out, well, what is x when y is 0? So now it's y's turn to be 0, and we need to figure out what x is going to be. So 4 times 0, that's nothing. So we end up with 7x is equal to 28. So I'm just going to kind of skip a little bit of a step and not rewrite it. I'm just going to kind of keep going there. And so we end up with x, because this is 1x. So it becomes x is equal to 4. And so now So when y is 0, x is 4. And so there is our completed table. And we can move that up here, get these guys out of the way. And so what do we have? What are our ordered pairs? We have 0, 7 as one ordered pair and 4, 0 as the other ordered pairs. We're going to take these ordered pairs and we're going to graph them. All right, and there's our equation. Okay, and let's make it a little larger because we can. All right, so where is 4, 0 going to go? Well, 4, 0 is going to go over here. 4, 0. 0, 7 is going to go, oh, I want to get this out of the way. 0, 7 is going to be way up here. And so we have 4, 0. We have 0, 7. And that is our resulting line. All right, again, we're going to be finding the intercepts. The only thing that's different about this one is the numbers just start getting big. You know, now we're dealing with 40 and 30 and 120, but really the mathematics itself is going to stay the same. The other thing that's different is they're kind of tricking us because they put the y first and then the x, but no big deal. So that's minus 120. So there is our equation. Now we're going to go down here. We're going to make our x, y table. And first x is going to be 0, and we're going to calculate y. And then y is going to be 0, and we're going to calculate x. So let's go do that. So we are going to go up here, and we're going to replace x to be 0. And we don't want to get tricked into thinking that x is always the first one. It's actually the second one this time. So we're going to get 40y minus, and then it's going to be 30 times 0 is equal to 120. And we know that that's 0. So we're going to divide both sides by 40. And we end up with y is equal to negative 3. So when x is 0, y right here is equal to negative 3. And so now we're going to let y be 0, and that's the first number. So it's going to be 40 times 0 minus 30x is equal to negative 120. And we know that this is equal to 0. So we're going to divide both sides by negative 30. And that becomes a 1. So we end up with x is equal to 4. All right, because negative 120 divided by negative 30 is 4. And so that's going to get small. And so x becomes a 4. And so there is our table down here. And so I'm going to get these guys out of the way. And really, what does this mean? So it means our coordinate pairs is 0, negative 3 is our first number. And then the second ordered pair is 4, 0. So now it's time for us to graph. So there's our equation. And then we're going to graph these 2 points. So let's zoom in over here. And let's see where that goes. So let's see. 4, 0 goes right over here. And I'll put a big old dot right here at 4, 0. And then 0, negative 3 goes down here. So there's our point, 0, negative 3. And then the line, boom, right there. There is our line for this equation. This one's just the same. The only thing that's different about this one is we've got fractions involved, but we're not going to let that freak us out, all right? So what we're going to do is first we're going to record the equation. So it's going to be 1/5 x minus 1/7 y is equal to 1. And they actually made it easy for us, and you'll see why in a second. And so there's our equation. And of course, when we want to find the the intercepts, we make a table, an xy table. And we know x is going to be 0. We're going to calculate y. Then y is going to be 0, and we're going to calculate x. And let's move that out of the way so that we can do our math up here. So the first thing we're going to do is we're going to let x be 0. So that's going to be 1/5 times 0 minus, and then 1/7 y is equal to 1. So now we know that this is going to be 0. So I'm actually going to make this a separate line. Now what are we going to do in order to get rid of that negative 1/7? Well, we're going to multiply both sides by negative 7 over 1, the reciprocal. So negative 7 over 1. And I'm going to move, well, no, there we go. Done. All right, so then this guy undo each other, and we're going to be left with just a plain old y equals. And then the right side, you've got 1 times negative 7. So that's going to be negative 7 over 1. And so y is equal to negative 7. So that's a lot of work to show that really y is equal to negative 7. All right, so right here is negative 7. And I'm going to shrink that. I'm going to get it out of the way over here, because now it's time to let y be 0. So we've got 1/5 x minus, and then it's going to be 1/7 times 0 is equal to 1. And then this becomes 0. So we end up with 1/5 x is equal to 1. And then we're going to multiply both sides by 5 over 1. And so 5 over 1 times 1 over 5, that equals 1. So we end up with just x is equal to 5. How did I get 5? Well, 1 times 5 is 5 over 1, and 5 over 1 is equal to 5. And so when y is 0, x is equal to 5. So there is our completed table. And so we know that our coordinate pairs are 0, negative 7, and then the other one is 5, 0. So we're going to move these things, get them out of the way. We're going to move our equation over here, and then we have our coordinate pairs that we need to figure out where they go. So 5, 0 is going to go here. 0, negative 7 is going to go down here. So 5, 0. 0, negative 7, and then here is our line, and I did not do a very straight one, and that is our line right here for this equation, is this line. All right, for this one, it's the exact same thing, only we are going to do a little bit of magic here. So when you have that equation right there, I'm going to rewrite it in a slightly different way. So it becomes negative 1/3 x, and then plus 1/4 y is equal to 1. So there is our equation. And again, of course, we're going to have the x, y table. And we know that x is going to be 0, and then y is going to be 0. So let's put it way down there to get it out of the way. And then, so let's start with x being 0. So we know that when x is 0, we're going to immediately get 1/4 y equals 1. So we're going to multiply both sides by 4 over 1. And so that ends up giving us y, because this 4 over 1 times 1 over 4, that equals 1. So we end up with 1y, which is equal to 4. So when x is 0, y is 4. So let's get that out of the way and put it right there. And now we need to figure out, well, what happens when y is 0? Now when y is 0, this is going to go away because they're being multiplied. So we're going to end up with negative 1/3 x is equal to 1. So now we need to multiply both sides by negative 3 over 1. Negative 3 over 1. And so, of course, this right here is equal to 1. So we end up with just x on the left side. And on the right side, we end up with negative 3. So when y is 0, x is negative 3. And that is our table down here. And so what are our ordered pairs? Well, our ordered pairs are 0, 4, and then the other one is negative 3, 0. So we're going to get these scratch paper out of the way, and then we're going to move our equation over here, and we're going to move our ordered pairs, and then zoom in here. Whoa, zoom in. And so let's see, where does 0, negative 4 go? Well, that goes right up here. And then let's put a 0, I think I said negative 4, 0, 4. And then where does our negative 3, 0 go? Well, that negative 3, 0 goes over here. And so we're going to have to do some rearranging here. Negative 3, 0 goes right there. And there, that gives us our line right here. Boom, done. All right, again, we're going to be finding the intercepts and then graphing the resulting problem. Now I'm going to show you another way to do this problem. So you've got x over 5 minus y over 3 equals 1. All right. Now the idea is some students don't like fractions. They go, ooh, I hate fractions. So that's fine. So what we're going to do is we're going to take 5 times 3, that's 15. And now we're going to multiply everything by 15. Everything, both sides, by 15. Now why are we going to do that? Well, the reason we're going to do that is because when we multiply by 15, so I'm going to rewrite that down here, we get 15x over 5 minus 15y over 3 equals 15. All right, so technically this equation and this equation are the same equation. This just has everything scaled up by 15, but they're still equal equations, right? Now what happens? Well, 15 over 5, that equals 3x minus, and then 15 divided by 3, that's 5y, and then the right side is just 15 because 15 times 1 was 15. So here, here is our new equation that we're going to be doing all of our information, that classic x, y table. All right, so x is going to be 0, then y is going to be 0. So they're each going to get their turn. I'm going to put that over here. So let's do first x equaling 0. So when x is 0, we end up with, let's see, 3 times 0 minus 5y is equal to 15. So that's really 0. So we're going to divide both sides by 5, negative 5. And so we end up with y is equal to negative 3. So that right here is our negative 3. And I'm going to take that work and I'm going to shrink it down because we don't need it. And now it's y that's going to be 0. So we're going to get 3x minus 5 times 0 equals 15. And then that goes away because that's 0. And now we're going to divide both sides by 3. And so you end up with x is equal to 5. So when y is 0, x is equal to 5. And so we're going to take our table and we're going to move our table over here because that gives us our ordered pairs. So the first ordered pair is 0, -3. And the second ordered pair right here is 5, 0. And we're going to take, now let's see if it works. Yeah, we're going to take that original equation and our two ordered pairs, and that's what we're going to graph. Okay, so where is 0, -3? Well, that goes down here. Where's 5, 0? It goes right here. And so 5, 0 is right here. 0, -3 is right here. And really, I should move that out of the way a little bit. And our line looks like that. So this is a different way to do it, in a way where we can get rid of the fractions and use whole numbers only, and some students prefer it that way. So here it's more of the same. The only thing that's tricky, and it's not really all that tricky, is the fact that, and we're not actually going to have to graph it this time, which is kind of cool. But the thing that's different this time is we have no numbers. So we have ax plus by is equal to c. And so what we're going to do is we're going to go down here, we're going to make that xy table, and we know that x is going to be 0, and we're going to calculate y. And then we know that y is going to be 0, and we're going to calculate x. So it's all the same, nothing's different, except that it's actually going to be easier because we have no numbers to contend with. So let's let x equal 0. So you're going to end up with a times 0 plus by is equal to c. Well, this becomes 0. So now we're going to divide both sides by b, and you end up with y is equal to c over b. And so that is what's going to go down here for y. Y is equal to c over b. All right. And so this scratch work, I'm going to put it away. All right. Now it's time for y to be 0. So we've got ax plus, and now it's going to be b times 0 is equal to c. B times 0 goes away. So we're going to divide both sides by a, and you end up with x is equal to c over a. And so, so this work tells us that x right here is c over a, and that is our two coordinates. So what this means is when x is 0, our y-intercept is CB. So that's right here. Y is equal to CB, right there. And when y is 0, our x-intercept is CA. And so that is going to go right here. And that is our answer for that one. So that wasn't so bad, especially because we didn't have to graph it. All right, last one. Again, it's the same thing with no numbers. We only have variables this time. But this, oh, so I don't even need the graph, do I? So let's get rid of that graph. All right, so now we're going to start with x over a plus y over b equals 1. All right. Now the first thing I'm going to do is I'm going to take that and I'm going to duplicate it just because I know I'm going to need it later. So I'm going to start with this. Now what am I going to do? Well, let's do that shortcut. I don't know if it's a shortcut. That thing that's going to allow us to get rid of our fractions. All right. So we're going to take a and b and we're going to multiply them together. That gives us ab. So now we're going to multiply everything by AB, and multiply by AB. So what are we going to end up with? Well, first we're going to end up with ABX over A plus ABY over B is equal to AB. And then we see that these A's cancel out, leaving us with just BX plus, and then we see that the b's cancel out, leaving us with AY is equal to AB. So now we are officially using this new equation right here. We are now officially ready to figure out our XY table. So I'm going to, let's see, get this guy out of the way. And here is our XY table. We know X is going to be 0, then Y is going to be 0. So first let's put X as 0. So that's going to be B times 0 plus AY is equal to AB. So that goes away. That equals 0. And now we're going to divide both sides by A, and you end up with Y is equal to, and the A's cancel out, leaving us with B. So Y is equal to B. And that's pretty straightforward and simple. So I'm going to put the scratch work way over here. So when X is 0, Y is B. All right. And then we're going to say now it's Y's turn to be 0. So you've got BX plus, and then A times 0 is equal to AB. That goes away. And so now we can divide both sides by B. And we end up with, these B's cancel out, so you get X is equal to, and these B's cancel out, X is equal to A. So now that we know that X is equal to A, get all my work put away over here, and X is equal to A. So there is our coordinate intercepts right here. Here's our intercepts, and the intercepts are when, let's see, get this guy out of the way. So what is our x-intercept? Well, when y is 0, x is A. So that A is your x-intercept. And what is our y-intercept? Well, when x is 0, y is B. All right, so there's no thing, you're not supposed to look at this and immediately know that. This is not something you're supposed to memorize. It is something you're supposed to calculate like I did over here. Definitely not something I want you to memorize.